All right, so we are looking at a bunch of different ways to solve equations within circles. So we're going to start by talking about something called a tangent line. Now this is different from tangent when we were talking about sine, cosine, and tangent. Tangent just means it's a line that touches a circle in one point, and that point is called the point of tangency. So that orange line right there is a tangent line to a circle. It is also perpendicular to the radius. So at that point of tangency, if you connect it back to the center, it's always going to be a right angle right there. Okay, and we need to know that for the remainder of chapter 10 because they're going to use that. Okay, so because it's a right angle, we're able to use right triangles in this. So looking at this one right here, if I tell you that this black line up here is 12, and then just from here on the outside of the circle, the T is 7, we want to find this radius, okay, which we can label x on both of them because the radius, no matter where you draw it on a circle, is going to be the same. So if we have a right triangle, what could we use to solve for x? We could either use SOHCAHTOA or a squared plus b squared equals c squared, the Pythagorean theorem. Which one can we use here?
Both.
Not both. What do we need in order to use SOHCAHTOA? We need an angle. Okay, we have the 90 degrees, but we don't have the other two angles, so we can't use SOHCAHTOA, but we can use Pythagorean theorem. Could somebody shut the door, please? Thank you. Nope. All right, so we're looking at this one right here. Which one is our c squared?
7x.
Yeah, this one right here. Okay, so that's going to be our c squared right there, but we're going to put the other two in for a and b. Now, how would we write this whole thing? Yeah, we're adding them together. Okay, so we've got x plus 7, and that also has to be squared. Okay, now when we square a quantity like that, we'll talk about that in a second. Let's just get this down first. This is 144. We can't simply just write x squared plus 49. That's not what that is. Okay, when we have a quantity squared like that, it's really taking x plus 7 times x plus 7. Okay, now an easier way to organize this is to draw something that I call a window and simply writing x plus 7 and x plus 7 on the outside. Okay, this is not lattice because we're not going to be drawing any diagonal lines, but what we're doing is we're just figuring out what the area of each square is. So if we take x times x, what do we get?
X squared.
What do we get here?
Or 7x.
Yep, 7 times x is 7x. Here,
7x.
also 7x, and here, 49. Okay, now we can put these two together, combine like terms, so 7x and 7x is really 14x, and your answer is always right here. Okay, so we've got x squared plus 14x plus 49 right here. Yeah, I think you did it last year. Okay, what could we do to both sides now? We could minus 49. What could we get rid of by subtracting it on both sides? X squared. So let's do that. That'll make life a little bit easier here. So now we have,
Well, yeah, they cancel each other.
yep, they cancel out. Okay, now this is just back to basics solving for x. So now we can subtract 49. What do we get there? 95? Okay, and then divide. What do we get? Is it 5? Someone have a calculator? 95 divided by 14?
How do you know which one you put in the square deal, like x7? How do you know? Is that each Like, is that the one? I know, but I'm asking why is it that one?
That we put in the window?
Yeah.
Because it's this whole quantity squared. Like this 12 right here, we wouldn't need to window anything because there's only one term. But we're squaring the two terms added together.
So is it basically the one with the variable and the number on the same line?
And the plus. Yep. Yep. All right, so if a line is perpendicular to the radius of a circle and crosses through the circle, then it's a tangent line. So this is just working backwards and saying, is this a tangent line? Well, the only way it's a tangent line is if this is a right angle. And if that's a right angle, then the Pythagorean theorem would work, meaning that it would be equal on both sides. So all we have to do is check with the Pythagorean theorem. Which one would go in for c squared? Okay. Put in the other two numbers here. I'm going to need some help with these bigger numbers. I know 49. What are these two? I think this is 625. Okay, so what are these added together? Okay, so because this works, the answer to the question is yes. We just proved that it's a right angle because the Pythagorean theorem works. Okay.
So if you already know the what's the one?
Hypotenuse?
Yeah, the hypotenuse, then you won't have to do the window.
Yep, this one is just working backwards. So this one has no variables in it at all. Other questions? Okay. Here's the next thing that's true. If we have two tangent segments, so both of these are tangent to the circle, they're equal to each other. So all I want you to do is put the symbol for equal segments on those. So if you have two segments that are tangent, we know we can set them equal. Okay, then we need these two vocab words. Inscribed means you have a shape that is inside a circle. So what I want you to do is, it doesn't have to be exactly the same as mine, but draw in any shape you want, any polygon that is perfectly inscribed in the circle. It could be 4-sided, it could be 3-sided, 8-sided. That is inscribed. Circumscribed is around the outside. So it's a bunch of tangent lines that barely brush the outside of the circle. This one's a little bit harder to draw. But each of them have one point of tangency where they touch the circle. Just like that. So you'll notice this picture at the top, right here, these are two tangent lines. What do we know about these two green lines? They are the same as each other. So we're going to talk about that on the next page. Okay. So if they gave you a picture like this and they want to know what is the perimeter of that orange polygon, we have to fill in these numbers. So notice there's a 10 right here. Can we draw a 10 anywhere else? Right next to it. So this one is 10. Okay, this 15 right here could also be written right here. This 9 up top can also be written here. Now, looking here, this 20 is talking about from all the way from here to there. So, but they did give us this 12 right here. So from here to here is how long? This part is 12, which means this part is, that would be 8, right?
Right.
Okay, because the whole thing has to be 20. So if this one is 8, then this one is, that one is 8, which means this one is, and 10. Okay, so now when we add these up, okay, let's back up. Somebody said they were lost. How did we get this 12 right here? There's a 12 right next to it. Now the whole thing is 20, so if that part was 12, then we subtracted from 20 to get 8. And then the next one to that is 8. And then we did the same thing here. But we don't want to double count these when we're adding these up. So we just want to add together all of these other numbers. Can somebody punch it in the calculator? Couple people to make sure. You can if you don't add in the 12 and the 8 and the 8 and the 10.
So
I just don't want you to double count it. What do we get for a grand total perimeter around the outside? A lot more than 36. 118?
what?
Any other numbers that we're getting?
Yeah.
I'm feeling like 89.
Well, I'm feeling you're wrong.
Oh, do that.
I think it's.
$128.
128 we're getting?
Yeah.
Okay. All right, let's move on. All right, so let's get some vocab on here, and all we're going to do is label this picture with the words that these segments and lines are. So we already learned this one. What is this called? This is a tangent line. That's when a shape is around a circle. What is this called?
Radius.
What about this one? Mm-hmm. Okay, and then we've got two that we haven't talked about yet. We have this segment right here. Okay, this is called a chord. I don't know. They just wanted to put the H in there. And this one is secant. When you have a line that goes all the way through a circle with arrows on the ends, so this is actually a line, secant line, goes all the way through the circle. Keeps going. Everyone got those? All right, last example. And this one. Okay, so if these are two tangent lines, here's what we know. We learned this, that those two green lines are the same. What else do we know about tangent lines with circles that we learned today? They're perpendicular. Okay, so right here, if these are both radius lengths, we know that these have to be perpendicular. Okay, we know the middle angle is 152. What shape is this green thing? It's a quadrilateral, but more specifically, a kite. Okay, so we have a quadrilateral that's named a kite. What do the angles add up to?
360.
Okay, so we've got x plus 90 plus 90 plus 152. That has to equal our grand total of 360. So what do we got here? X plus what? How much? 322?
That's 180. Oh, no, 332.
It's 332.
Okay, and then we subtract. Any questions?